Hello. Today I'll be explaining about helium neon laser. You might have heard of different types of lasers are there, but today I'll be just focusing on helium neon laser. What is laser? Laser is the abbreviation for light amplification for stimulated emission of radiation. The first gaseous laser was demonstrated by Ali Zawan in 1961. This helium neon laser is basically an atomic laser which works in the principle of four-level pumping scheme. So by hearing this word pumping scheme, it comes into mind that what is pumping. So the first thing, pumping. Pumping, by the word it only you can know that pumping is a process in which the atoms which are present in the ground state is excited to higher energy state. Higher energy state. By providing some energy. To maintain this pumping process is required in the laser technique because the population inversion, which is the basic technique of laser, it must be maintained. And there are different types of pumping scheme. There are 2-level pumping scheme, 3-level pumping scheme, 4-level pumping scheme. This helium neon laser basically uses 4-level pumping scheme. And these pumping can be done by 4 processes. The first one is optical pumping. The second one is electrical discharge. The third one is direct conversion. And the fourth one is inelastic atom-atom collision. This helium neon laser, in which 4-level pumping scheme is used, it uses inelastic atom-atom collision. Now, in this helium neon laser, there is basically a mixture of 10 parts of helium and 1 part of neon, in which the helium atom are used to excite the neon atoms which are present there. And the neon atoms are basically the active centers for the stimulation. Now, I'm just going to explain how this works. And this is a rough schematic diagram of the helium neon laser. What happens is that this is a mirror, these two are mirrors, and with here laser beam is coming out. This is a Brewster window. This helium neon mixture which I talked about is basically kept into a Pyrex tube. This is a Pyrex tube which is 10 cm long and its diameter is 2 mm. Now a Brewster window, you can see these are the Brewster windows. These windows are used to minimize the reflection losses so that the output is high. Now the working process. How this helium neon laser works. When you can see that electrical discharge is given here and helium neon is getting excited and the laser beam is coming out. What happens that when 10 kilovolts of electrical discharge is given, due to that electrical discharge, what happens that electron and ion are produced. The electron which is produced and the ion which are produced, it accelerates toward the anode and cathode respectively. Now, what happens that the electrons, as you know that electrons are having very less mass, so it gains a very high velocity, and due to it acquires a high energy and it transfers that kinetic energy to the helium atom, and that helium atom excites to the F2 and F3 level of the metastable states. I am explaining it with a diagram. You can see I have made a figure in which this helium atom, after gaining that kinetic energy, which when the electron strikes it, it goes up to F2 and F3 higher energy state. In this F2, it is having energy of 19.81 electron volt, and in that F3, it is having 20.61 electron volt. What happens that these two are metastable state of helium. So this helium atom can't return to the ground state, because there is no spontaneous emission or radiative emission taking place in this process. So what it does, it basically transfers its energy to neon atom. Then by transferring its energy, it's 20.66, 0.05 electron volt of extra energy is used. What happens that the neon atom, which is present initially in the ground state, it excites up to E4 and E6 level, and so that the helium atom, which is present in F2 and F3 level, it go back to the ground state. Now this E4 and E6 neon atoms get excited and stimulated, and this how the laser works. What happens that in this laser, when the neon atom get excited, the photon is produced along the parallel axis of the tube, and this photon is basically responsible for that laser which is being produced. There are various type of transition taking place in this type of laser, this technique. There is E6 E3 transition, there is E6 E5 transition, and there is E4 E3 transition. In this E6 E5 transition, 3.39 mu m of wavelength is generated, and in that E4 to E3, 1.15 mu m of wavelength of light is generated, and in the E6 to E3 transition, 6.3 to 8 angstrom of red laser is generated, which is being used here. And you might be confused that why not E2 and E1 transition is taking place. E2 to E1 transition does not take place here. We can stimulate this transition by focusing the energy into the reflecting walls of the mirror, which I made it previously. And there are various uses of helium neon laser, and which you will know afterwards. And this is the thing which I explained about helium neon laser.